Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to the online lecture on MATLAB simulation of control systems research papers. Today I'm going to make a short video regarding the issues in simulation of the results in a research paper. Before that, I created a video that was about how to simulate a research paper, but that video did not cover this aspect of what would you do if you are trying to simulate a paper and you're not being successful at it. I myself have failed in simulating research papers many times, and I'm sure many of you have faced similar problems, especially at the beginning of your research career. So let's look into this issue. So what are the common problems? First of all, if you look at the research paper, sometimes values of the parameters are missing. So for example, if there is a research paper related to electric circuits, then let's say control of a permanent magnet synchronous motor, the values of the inductances, resistances, voltage reference values, and rated parameter values, all of those values are required for simulating the paper, must be present in the paper. Sometimes the equations are not well described, so you struggle in understanding those equations. Sometimes there is error in equations, which, you know, if you are not familiar with the field or the topic, then you cannot determine whether there is an error in the equation or not. And when you write the code and you run the code, the graphs do not match those in the paper, so you don't get the same graphs that are presented in the paper, because you know it is very easy to have typos or errors in the equations, because papers usually involve a lot of equations, and there are so many versions before they get finally published, so there some things get mishandled, you know, in the journey. Authors assume that reader knows. This is this is very common with authors, especially the new researchers. It is not very easy to write a research paper that is friendly for everybody. So only a few authors which are, you know, have been writing papers for many years, they understand this kind of things, and hopefully you will you will come across papers, you know, where you will not understand fully how the equations are being derived and where different equations come from, but that is because, you know, there is a lot of background information that cannot be incorporated in the paper because of the lack of space. Equations are too many or too complex. This is also an issue, because for this kind of papers you have to be very careful and very slow, I would say, in order to be accurate. In terms of the parameter values, it is a good practice to, you know, list down all the parameters in the equations of motion and in the equations of the control law, and look for the values of those parameters in the paper, and then search for the values in the paper, and then read the text of the paper about, you know, regarding any assumptions about the values of the parameters. Then sometimes the parameter values have been borrowed from a reference, so you have to be careful while trying to simulate a research paper that, you know, they should, whether they have provided all the parameter values, or sometimes author would just say that we have used the parameter values of such and such reference paper. In the equations, focus on the equations of interest only. You can ignore the proofs and ignore the derivations while you are, you know, trying to simulate the paper. Make sure that you understand what each variable means. It should be the paper should be describing all the variables for you. Identify the substitutions of variables if required. Sometimes a variable in an equation basically is described by another equation in the paper, so you have to be careful, you know, where all the variables are and, you know, how they are defined. previous knowledge of the topic. If you do not have the background knowledge about the topic, you may need to refer to an older paper or a textbook. And sometimes the authors skip a few intermediate equations, assuming that the reader already knows. The calculation of, for example, the calculation of linear approximation in control systems papers, readers will not walk you through all the steps of linear approximation. They will just tell you that this is the nonlinear system and this is the equilibrium point, and we linearize this about the equilibrium point, and here are the linearized equations of motion. Similarly, there are different errors in the code. So if you get any error in the code, then please read the error statement very carefully and even search it on the Google. It will help you a lot. A lot of error statements are self-explanatory and they will tell you how to fix the error. And if not, then you can also search them on the Google. There are so many platforms, discussion forums and pages where people have discussed the solution to those errors. Make sure that you have copied the equations correctly. Sometimes there are typos in the equations and there is no way of knowing unless you are well versed with the topic. And the most important is to move on. So do not spend too long on the simulation of one paper. 1 week is max. You have studied the paper. I'm assuming that you have studied the paper and you're ready for simulating it. Then you start simulating it. You first day you write a few equations on the MATLAB, and second day you write more equations, and third day maybe you're completing all the simulation equations, and you run the code and the code is not running, and you spend 1 or 2 days debugging the code. And then finally when the code runs, if the plots are not the same as the ones in the paper, then you get frustrated. Don't be frustrated for too long. If it works, then it works. If it does not work, then there are so many other papers waiting for you to try them, and there are hundreds of the papers on the similar or same topic that you are trying to do research on. And sometimes you may need to refer to an older paper for better understanding and clear concepts. Try to pick paper from the top publishers. So now that I have walked you through some bullet points, let us actually look at some research papers and see how we go about. For example, this is adaptive neural network control for non-strict feedback nonlinear systems with input delay. So first of all, you have to understand what this paper is all about. So this paper is presenting some adaptive neural network control. So when you are reading the paper, you will be looking for the control law that is based on some sort of adaptation. So there will be some adaptive parameter in the control law, and then there will be some sort of neural networks in the control as well. So there will be some delay in the input of the system. Input is the control of the system, so control will be applied to the dynamics of the system with some delay involved. Now abstract, you don't simulate the abstract. So from the simulation perspective, abstract and introduction, please do refer to my previous video where I tell you how to go about simulation of the paper. Before coming to the actual step where you actually simulate the paper, there are some steps where you shortlist the papers and you read their abstracts and you read their introduction. So this video is relevant only when you are at the stage where you are ready for simulating the paper. So I will assume you have already read the introduction and abstract before coming to this stage. Next, you look at the basic equations. Sometimes the basic equations are given out front, and sometimes a more relevant version of these equations is given later on in the paper. So in this paper, this equation is basically representing the generic form of the systems. So this if we have to create a simulation example, we have to make it more specific. Then there is this definition of this radial basis function. Of course, we were expecting the neural network, so there is something relevant to that. Then there is this type of equations which are the auxiliary system. So auxiliary systems are usually the systems that you need to incorporate into your codes. This is an example of some additional equations that are to be incorporated into your control simulation. So control design process, this whole process, the steps are given, you can ignore all the steps, and but you cannot completely ignore all the steps, because you will have to come back to these steps later on when you look at the, let's suppose you keep on scrolling down, and then there are so many equations in the paper. Not all of these equations are going to be used in the simulation. So now these kind of things are very, very important. So if there is a theorem in the paper, your work is reduced by a lot, because this will clearly tell you that the closed loop system will be equation 1, control law will be equation 41, so this will be the control law. Then the adaptive laws will be equation 35 with I is equal to 1 to n. So this will make the system closed loop boundedness. So this will achieve boundedness. So now you know that in order to simulate the results of this paper, you will be using the equation 1, 41 and 35. But if you look at the equation 41, there will be some parameter like theta n hat and phi and lambda. So these, all of these parameters, they have been defined previously in the paper. And also this equation 41 has associated equation 42, which is understood that if you are going to use this variable lambda hat, you will have to use the derivative of lambda hat as well. So this is implied that if you're trying to use 41 in your simulations, 42 will also be used. Now if you look at the other parameters, like for example kn, zn, then you have to go upward, and you have to see where zn is defined, where kn is defined, where alpha i's are defined. So alpha I is equal to minus ki and so on. So this is the equation. This is again theta hat I dot, which is similar, which is basically the equation 35, which is basically very similar to equation 42. So this is equation 42 is for theta hat n, and this is for theta hat I. So where I could be from 1 to n or something like that. So in order to do that, you will have to read a little bit more into the paper. For first you identify which equations you need, and then in order to understand how these variables or parameters or constants are defined, you have to go back into the paper and study that in some depth, where you can know how to simulate this. By the way, this paper I have already simulated, so I will put a link of MATLAB coding that is relevant to this paper in this video, so you can go to that video and you can see how I simulated it, and then you will know that which of the variables I use. For example, this capital X n, this is defined here, so this you will be using this because phi is the function of capital X n. So you have to know what capital X n is and what capital phi is. So for capital phi, you probably have to go up and look into like the beginning of the paper, where they define phi. So here the phi is something like phi of z, and phi of z is this function, and this is a radial basis function, and then within phi of z there is like this si of z are there, which are these equations. So in fact, for a beginner, I have been able to simulate this paper to some extent because I have some experience in simulation of papers. But for a beginner, this is a very tough paper, and the information, in my opinion, the information is not very comprehensive. So this is one of the papers where you can say that authors assumes that the reader knows some basics. So if you don't know any basics about iterative learning or how it works, and how do you define different things, then it will be very difficult for you to go through this paper and simulate it. Similarly, we look at another paper, iterative learning control. So this was adaptive neural network paper, and now this one is the iterative learning control, and I have also put a video about how to simulate this paper on my channel, so I will post the link of that video here as well. So again, you have to look into the equations of the system. These are the generic definitions and sizes of the vectors and everything, and then there is some intermediate equations that you can ignore, but you have to read through the paper in order to identify. So this is the control law, that is the main thing that you need in order to simulate. Again, there is some sort of parameter theta hat recursive control part that is used to learn the unknown function theta, and then v dot is the associated equation. And then here again, in order to implement this control, you will have to deal with this theta hat k, you will have to deal with this v of k, which has its own dynamics. So any variable that has its own dynamic needs to go into the code as well. So you can look into, so this theorem will be very useful for you, which will identify what equations you need. So sliding surface is equation 5, 6 and 7. Second order continuous sliding surface proposed in 5, 6, 7 can guarantee that the system output tracking error will converge to. Here the system equation is not referred to, but if you look up in the paper, you can identify which one is the system equation. So again, this is the system equation, but you can also go down to the here there are some parameter values again in the other paper as well. If you go down to the numerical section, you will see some parameter values. They will be given somewhere. So maybe, yeah, here there are some values of the parameters and some initial conditions, and there are some definitions, assumptions. So all of these you have to go through and try to understand. Now coming back to this thing, so first of all, just look at a couple of videos that I have posted the link in the description of this video, and see how I simulate the paper. But if you are trying to simulate a new paper, then first thing you need to do is look at the parameter values, then identify the equations, and within equations there are some equations under equations. So these substitutions you can see here in this paper. When you go here in the control law, there are some substitutions or associated equations. So here you cannot use this as it is in the code. There will be some associated equations that you will have to incorporate as well. So finally, if we summarize that The issue will be if the parameter, if you cannot find the parameter values, that is an issue. If you are unable to make sense out of all the equations, that is an issue. If all the equations make sense and you write the code and the code does not generate the graphs that are actually presented in the paper, that is another issue. But there the error could be in the equations, but mostly the error is in your code as well. And also sometimes authors assume that reader has some background information, which if you don't, then you have to refer to an older paper. Then if the equations are too complicated or there are too many equations, I suggest that you be slow. And if all of this you have done, then you have to and still if it is not working, then you have to move on. The most important step is to move on if you're unable to go through with it. And also stay in close contact with your research supervisor if you are a beginner. So I hope that this video was somewhat useful for you. It is not going to solve all your problems, but maybe it will give you some hints about how to write the code, or how to identify why your code is not working.